In this new example for section 2.4, we have to find the solution of the equation given in the problem. So this equation might be exact because it's given in a form indicating that might be solved using the exact method. So first of all, we need to identify m. M is that expression in front of the x, and that is x sine of 2y, correct? And then n, it is that expression, n is that expression multiplying the y, which is x to the second cosine of 2y minus 3. So we have to test, we have to prove that, or if the equation is exact. For this reason, we need to compute the derivative of m respect to y. So the derivative of m respect to y is going to be simply 2x cosine of 2y. Remember, in this case, when you find the derivative of a function with respect to y, x is like a number, x is like a constant, like a coefficient, I would say. So derivative of sine of 2y is basically what you have to find, which is cosine of 2y times derivative of 2y, which is 2. Derivative of n respect to x. Okay, in this case, y is going to act as a number, as a coefficient or a constant. So to find the derivative of n respect to x, x will be the only variable. So that would be what? 2x cosine of 2y. Correct? Okay. So this derivative is the same as this, so the equation is exact. Okay, these two expressions are the same. So what do we have to do now? Our solution is a function on x and y is going to be the integral of m of x comma y dx plus some function depending on y. Okay, so our integral would be the integral of x sine of 2y dx plus gy. So the integral of x sine of 2y dx is, remember, this integral only depends on x. This integral only depends on x, right? So x is going to be the variable. Everything else is like a number. So the integral of x is x to the second divided by 2 sine of 2y plus g of y. Now we have to determine who g of y is. Who is g of y? Well, to do that, we have to find the derivative of f respect to y, and that is going to be equal to n of x comma y. Okay, remember this expression that I'm going to show you now in green, all this in green, is equal to f of x, comma y. So this expression now we're going to integrate it, to differentiate it respect to y. So we have that the derivative of this expression is going to be x to the second divided by 2, because remember now the derivative is respect to y, and the derivative of sine of 2y, which is cosine of 2y times 2 plus g prime of y. And that is equal to n of x comma y. And what is n of x comma y? N of x comma y is that expression given in the original equation that is multiplying dy. And that is x to the second cosine of 2y minus 3. So these two cancel these two. We have x to the second cosine of 2y plus y prime of y equals to x to the second cosine of 2y minus 3. These two terms are the same, so they cancel. So g prime of y is equal to -3. Then when we integrate g prime to find gy, that is going to give us -3y. So our function, our solution is what? The previous integral we found, x to the second divided by 2 sine of 2y plus g of y. What is g of y? Well, we just found it. G of y happened to be -3y. And then the way to express the solution is f of x comma y equals to c. So what's going to be the answer? The answer is going to be x to the second divided by 2 sine of 2y minus 3y equal to c. And that concludes the problem.